let's get on notes for linear versus nonlinear functions. It will not be on your to-do list. Remember that you can find it under modules. So you'll go to Unit 2, and I have it highlighted. Linear versus nonlinear. I'm going to run through this really quickly, okay? So y'all will need to slow the speed down, or on the video if you need to. She could also pause it for you. But I'm going to try to move through this kind of quick because I was a little late doing this. Okay, so I'm going to do Notability. If you're still using Canvas, take your notes in. You're going to lose like half of them. Please make sure that you are using, was it Noteful, I think that you guys have? That's really good. Okay, so linear versus nonlinear. A lot of you probably remember this. So let's get started. A function that is linear will have a constant rate of change and can be distinguished from nonlinear functions in each of the following representations. Okay, so we've got equations. We will learn more about this type of equation next unit. It is in the form, it's called slope-intercept, so it's y equals mx plus b. You get to learn all about the m and the b next unit. So get excited. Okay, linear tables. It's a constant rate of change. That means that the x's are going about the same value every time, and the y values are going about the same value every time. It can be going down, so up or down. Okay, a constant rate of change as the x values change by a constant value. The y values also change by a constant value. So here's the quick example. If we use this one, this is plus 3, this is plus 3, and this is plus 3. So they're all the same, so that's good. This one, plus 2, plus 2, plus 2. And these are all the same. So it is a constant rate of change. If there was one that was different, then it would not be. So that is a linear function. And then we got linear graphs. The graph will form a straight line. I know you guys probably remember that part. Okay, so it says use the given equation to fill out a table of values and create a graph. Then identify the function as linear or nonlinear. Justify your choice based on each representation. All right, we got y equals 1/2 x. So this means that we're multiplying 1/2 by my x values. We got 5 of them. So you can use decimals if you want to, but if you do y equals, we're going to fill in this one. So 1/2 times -4. If you need the calculator, that's fine, but this is basically just half of 4, or half of -4, which is -2. Half of -2 is -1. And then we've got 0. Half of 2 is 1. And half of 4 is 2. Okay. So remember to slow the video down because I'm doing this really fast. So -4, -2 would be here. -2, -1 here. Wait. That doesn't really fit. No, maybe it is right. Okay. And then 2, 1. And 4, 2. And it does form a straight line. So we're going to answer the question. Linear forms a straight line. You could also, instead of that, put that it has a constant rate of change, but it basically means the same thing. All right. Anytime you see an exponent, it is nonlinear. So that's basically what makes an equation nonlinear. So if it doesn't have an exponent, it is linear. If it does have an exponent, it is nonlinear. So this one's kind of a little, it's not difficult, but it's kind of complex. We have to fill in each of these for x, but you need to remember that whenever it's negative, you need to put parentheses around it. So when we change the -2 out for this x, we're going to rewrite this as y equals, and we can't just put -2 squared. We have to put that in parentheses. Okay, so -2 squared, and then plus 1. So you can use decimals if you need to. -2 squared is -2 times -2, which is 4, plus 1 is 5. Okay. Then -1 squared would be just 1, and plus 1 would be 2. Anything times 0 is 0, so that would just be 1. And then we could do, I'll show this step, like y equals 1 squared plus 1, that would be 2. And then for the 2, same thing as the -2, we kind of caught a pattern here. So let's graph our points, -2, 5, -1, 2, 0, 1, 1, 2, and finally 2, 5. So this forms a curve. Let me see if I can draw it. I'm really bad at that. That is actually called a parabola, and you guys will learn more about that next year. But it's not a straight line, so it's nonlinear. Not a straight line. And also, it has an exponent in the equation. So exponent. I know I keep reminding you, but I'm rushing through this. So please slow it down or pause it if you need to. All right. We're just going to do a couple examples here. We got x cubed. So you're just going to type in each one of those for x. So in your calculator, just type in, like for instance, the first one would be -2 cubed. Do not forget the parentheses. You will get the wrong answer if you do that. Okay. 2 times, that'd be 8. Wait. Is it 9? Actually, I'm confused. Okay, let me double check myself. It's too early for this. All right. I think it should be negative. Okay, so negative parentheses, -2 to the third power. Yeah, -8. Okay. -1 cubed is -1 times -1 times -1, which would be -1. Let's see what 0 to the third power is. 0. 0 times 0 times 0. And then 1 to the third power is still going to be 1. And then finally 8. So that looks like it's going to be a parabola as well. So -8, -2, we'll plot that. -1, -1. Wait. Yeah. And then, what did I do? Oh, did I do something wrong? Oh, they're going by 2s. They're going by 2s. We got to watch for that. So -2 is here, and then we go to -8. Which would be down here. And then -1, which would be kind of between the 0 and the -2. -1, -1 would be kind of like right here. And then 0, 0. And then 1, 1. Okay, I thought I was doing something wrong at first. No, this is right. And then 2, 8. This is a very narrow one. Still a parabola. It is non-linear. Okay, so you guys can use Desmos on that. Please make sure to use parentheses. And you do have an assignment after this, though. So it says, Todd noticed that both proportional and linear relationships form a straight line when graphed. And he concludes that all linear relationships must be proportional. Do you agree or why not? Well, I'm not there to actually take your answers to this, but basically, a proportional one is always linear, but it goes to the origin. That's what sets it apart. So a proportional one is always linear, but a linear one is not always proportional. So he has it backwards. So we'll say, no, all proportional are linear. Okay, the next one's pretty simple. Remember that if it has an exponent, it is nonlinear. So this first one's Dawn. Letter B does not have an exponent, so it is. So we'll just put linear. I'm going to put LIN. And then when we divide by x, that is going to be linear. Multiplication or division is fine. Okay, and on number 8. Let's see. Okay. Let me try to do the homework with you. Okay, so number 8. Remember that there's usually going to be 1 or 2 answers. There could be more than one because it says circle the name of any student. So just kind of watch for that. There may be more than one answer. So let's take a look at this one. It says Tabitha says the relationship is nonlinear because as x increases, y decreases. So it can one can increase and one can decrease. That's fine, but it has to be by the same amount. So she's wrong. Arturo, the relationship is nonlinear because as x changes by a constant value, the y values do not change. Well, let's test it out. This is +2, +2, +2, +2. We're good there. Now this is -4, and then this is -12. So that's not. So he is right. That is not correct. Luke says a graph of the relationship would not show a straight line. Says it's not linear. It wouldn't. So he's right. So there are 2 people that are correct there. All right. Sorry I had to run through that really fast. Hope you all have a great day. Bye-bye.